Welcome everyone to this lecture where we're actually going to construct our very first TensorFlow neural network. We've learned about all the pieces that work with TensorFlow, such as sessions, graphs, variables, and placeholders. And with these building blocks, we can now create our first neuron and our neural network. We're going to create a neural network that performs a very simple linear fit to some two-dimensional data. That is, we're going to have some features, and then we're going to just say, what is y given this x? So our steps are the following. We'll build the graph, initiate the session, and then feed data in and get some sort of output back. And we're going to use the basic components such as placeholders, variables that we've learned so far to accomplish this task. So what is our graph actually going to look like when we design this linear fit? Well, it should look like, in matrix form, something like wx plus b is equal to z. And you can see here that it has lots of parallels with a simple linear line of y equals mx plus b, except that we're kind of choosing different variable terms here to line up more with kind of the classic neuron. So we're going to have a weight variable, w, and then we're going to multiply it by a placeholder object, x. So that's where we're actually going to feed in our data. Then we're going to have an operation, a matrix multiplication, and then to that result, we'll have another node in the graph, which is going to be another operation where we add in that b variable. Then we can pass it into an activation function, such as the sigmoid function. Afterwards, we can add in the cost function in order to train your network to optimize the parameters, such as that w term and that b term. Let's go ahead and build out this neural network. We're going to start with just a really simple review of using placeholders, variables, graphs, and sessions. Just going to do some simple additive operations and multiplicative operations. Then we'll actually build out the neural network. Let's jump to a Jupyter Notebook and get started. Okay, first thing to do in the notebook is a couple of imports. I'm going to import NumPy as NP and TensorFlow as TF. And then I'm also going to be setting some random seed values here. That way you can make sure you get the same random results I do. And TF, or TensorFlow, also has a set random seed. So I'm going to say np.random.seed, set it to 101, as well as TensorFlow's random seed. And you want to make sure you run these cells in the same order I do. If you run a cell more than once, you may not get the same random numbers that I'm getting here. So pay attention to this little in-count operator, and you can always restart everything by just saying kernel, restart and run all, or you can just go cell, run all. Let's come over here and create some random data. So this is just for demonstration purposes. I kind of want to show you how you could build a very simple session for simple operations such as addition and multiplication. Once we have that down, we'll actually create our neural network. Right now, I'm just going to create some random data points. So we'll say numpy random.uniform going from 0 to 100, and then let's ask it to be in the shape 5 by 5, and let's get our random data out. So here we have a random array, and you should have the exact same number of values I do here. Then we're going to do the same thing for random b. np random uniform, and the only thing that's going to be different here is the shape of this. Instead of 5 by 5, it's going to be 5 by 1. And then if you want to check it out, it should look like this. And again, you should have the exact same numbers I do here. If you are concerned that you're not getting the same numbers, just run this seed in the same line or the same cell as these random uniforms. Up next, we need to create placeholders for these random uniform objects. So let's go ahead and create them. I'll create two variables, a and b. They're both going to be placeholders. And the only thing I really need to provide here is what data point or what data type I expect. So we'll say tf float 32. Then we're going to say b is equal to tf placeholder tf float 32. Later on when we talk about convolutional neural networks, that shape parameter is going to be more important. But right now, a and b, just default shape none is fine. TF float 32 for both of them, that's totally fine. Now let's create some operations. Two really simple operations, just additive and multiplicative. So there's two ways I could do this. One is I could call these methods off of TensorFlow. So there is an add operation directly off of TensorFlow, and if you do shift enter here, it says returns x plus y element y's. The other thing I could do is if you call multiply here, multiply, TensorFlow has that as well, and it performs x times y element y's. And then it also has matrix multiplication, matmul, and it says multiplies matrix A, matrix B, etc. But what's nice about TensorFlow is that it can actually understand the built-in Python operations or operator symbols. So we can say A plus B, and it's going to understand when we actually pass that into our session that I'm just asking for an addition there. So now I'm going to also say mul op for multiplication operation is equal to A times B. Now what I'm going to do is create some sessions that they can use graphs with feed dictionaries to actually get results off of these operations. I'll type out with session as SESS. I want to get the result of this add, and I will say session or ses.run, and then I need to pass in the operation as well as a feed dictionary. So we have our operation here, add op, and that's going to add A plus B. But remember, A and B, those are placeholder objects, so they still need data. And the way we provide data using TensorFlow is with a feed dictionary. So our feed dictionary is going to be a dictionary where the keys are the actual placeholders, and then the values corresponding to those keys is the data that is to be filled into those placeholders. For example, I can say A is going to be the value 10, and B is going to be the value 20. So then I can say print add result, and when I run this, I should see 30 because 10 plus 20 is 30. Now we can go ahead and instead of just saying 10, we're going to add in our random data here. And now when I run this, I see the results of adding those together. And this is a matrix addition because remember I had a 5 by 5 and a 5 by 1 here, but you get the idea that essentially you're just having a feed dictionary, have a placeholder, and then the data you're going to feed it. Let's do the same thing for our multiplication result. So we'll say multiply result is equal to session run, and then our multiplication operator. We have a feed dictionary here, and then same thing, we can say rand A, and then B is rand B. And then we're just going to print those results. So we'll say multiply results, run that, and now we should see two results here. So we see two matrices, and if you want, you can add a print new line so they're a little more spaced out. There you have it. Okay, so that's a really simple example of running a session to create a graph with a feed dictionary. Up next, in the next lecture, we're actually going to create the example neural network that we discussed in the slides. I'll see you there.